Modern AI systems can feel like a black box of inexplicable magic, but under the hood, they operate exactly like a highly organized step-by-step assembly line. Let's feed it a task: book a flight for my upcoming company meeting. The sentence is chopped into data pieces called tokens, which is tokenization. Plotted on a mathematical grid, related words like flight and airplane group tightly together. This is vectorization. At this point, the AI hasn't solved our problem. What it has done is successfully translate our human language into a mathematical format that the machine can actually process. Now, the system has a pile of mathematical coordinates. The challenge is figuring out which of those words matter most to the overall meaning of our request. To solve this, data moves into the transformer, a central engine designed to process every coordinate simultaneously. Inside, a mechanism called attention mathematically weighs connections, drawing a heavy line between meeting and flight, so the system knows it's a business trip. Together, the transformer architecture and the attention mechanism give the AI the ability to comprehend the full context of a sentence, instead of just staring at isolated words. The AI now understands we want to book a business flight, but it hits a wall. It doesn't know our corporate budget or the specific meeting dates. To give it this information, ask yourself, should we completely rebuild and retrain the entire foundational engine from scratch every time our company travel policy changes? We could try a method like fine-tuning, but baking facts permanently into a model's weights is slow, expensive, and highly inefficient for dynamic information that updates frequently. Instead, we use retrieval-augmented generation, or RAG. The system pauses, reaches into a separate vector database, and pulls the exact travel policy and meeting dates directly into the engine in real time. By separating the reasoning engine from its factual memory, RAG effectively turns a closed book exam into an open book test. Even with the right context and the correct facts, a standard large language model is still stuck. It can generate text telling you how to book a flight, but it cannot actually perform the physical task for you. To bridge that gap, we route the output into an AI agent to apply reasoning to external tools. It uses the Model Context Protocol, or MCP, a standardized adapter plugging into outside services like a booking API. The agent sends the parameters through the API and successfully executes the transaction. Agents and protocols like MCP take a passive text generator and turn it into an active participant capable of navigating the digital world. Let's step back and look at the complete journey our text prompt just took, from raw input on the left to a confirmed booking on the right. We can group tokenization and vectorization into our first functional category, Phase 1, data prep. The heavy lifting in the middle section, where transformers, attention, fine-tuning, and RAG operate, becomes Phase 2, brain and memory. And the final step, where agents and MCP bridge the gap to external tools, stands alone as Phase 3, execution. Mastering AI architecture doesn't require memorizing endless technical buzzwords. It only requires understanding how these three phases work together to transform an idea into reality.